Yeah, like I said, what will happen is when we get to these word problems, it won't tell me find dz dt. We'll have to know what we're finding. So for a square with side length s, whose area is changing as time passes, find the following. Okay? This is working our way up here. All right, dA dt, I want to find dA dt in terms of ds dt. So here's the thing. Another thing will be, it's not going to give us the formula usually. We have to usually write down a formula that we're going to use. So that would be our first step. What is the formula here? Well, I'm talking about the area of a square, right? So you'll have to draw back on your knowledge of geometry formulas or look at the front of the book there for them. What's the area of a square formula? Area equals side squared. Area equals side squared. Okay. They're in the front. Okay, if you need to reference them. Most of them are. Okay, so I want to find dA dt. So this is just what we were doing with the x's and the y's. What's dA dt? Well, d dt, both sides. d dt, these guys. A is nice because it's just a. So it'd be, the derivative is 1, but I'm doing the derivative with respect to t, so it'd be dA dt here. And then what about the right side? What's the d dt of s squared? Be 2s. What else? ds dt. Okay? All right. What is the rate of area? So b, 1b. What is the rate of the area? What is the rate the area is increasing if the sides are increasing at a rate of 6 centimeters per second and the sides of the square are 30 centimeters long? This is what I'm saying. That is all in words. What is it in symbols? Well, I'm looking for the rate the area is increasing. Isn't that dA dt? The sides are increasing at a rate of 6 centimeters per second. What is that? The rate of the side increase? Isn't that ds dt? So ds dt here is 6. And the sides are, we want length of 30. That tells me s is 30. So this is just like the previous problems. I just have to decipher what they mean. Okay, so using dA dt, what we found there, so dA dt does equal 2s ds dt. dA dt is going to be 2 times s, which is 30, times ds dt, which is 6. So that is 60 times 6, 360. And then just a quick word about the units. What are my units going to be? Well, the units are going to be, look over here at dA dt, it's going to be the units of A. What's the units of our area? Area are square units. So in this case, I've got centimeters, so it's centimeters squared. So it's the units of A over units of T. And we're talking time, so that's centimeters per second. So the area is increasing 360 centimeters squared per second in that scenario. With me? Okay, well, let me try to get at least one more of these. Volume of a sphere expands as time passes. Find the rate at which the volume is changing in terms of the rate at which the radius. Okay, so this is pretty easy. We're going to start, like I said, you start with your formula. Volume of a sphere. Volume of a sphere is 4/3 pi r cubed. Is that what you said? Okay. Yeah, those are, they're in that little sheet here. Most of them are. Some of them may not be. Okay, so that's first step. Got a formula. Good. What am I looking for? The rate at which the volume is changing in terms of the rate at which the radius is changing. What is that telling you? What am I looking for? The rate. That's dV dt, isn't it? So I need to ddt these guys right here. ddt it. So that would be dV dt, wouldn't it? On the left, equals 4/3 pi. Now, note, what's 4/3 pi? Isn't that just a constant? So it's just 4/3 pi times, what's the ddt of r cubed? 3r squared dr dt. So clean that up. The 3's cancel, don't they? So it's 4 pi r squared dr dt is dV dt in terms of dr dt. Can I do one more? Then we'll do the next one next time. Yeah, if the area of a rectangle is decreasing at a rate of 4 meters squared per second. Mention this one because we probably want, that's area, that's dA dt, isn't it? And it's decreasing, so I probably should call that negative. dA dt is negative 4, and the length's decreasing at a rate, so dL dt is negative 1.5. Find the rate at which the width is changing, so I'm looking for dW dt. Length is 10, width is 8. That's all my given stuff, isn't it? With me? Okay, so that's just writing it, all the information down. What do I need next to write down? Need a little formula, don't I? Here I'm talking area of a rectangle. What's the area of a rectangle? That's the easiest one of the bunch, isn't it? Length times width. What am I looking for? dW dt. So I need to ddt everything in this formula. ddt it. What's the ddt of A? That's dA dt. 1 times dA dt, technically, if you want to get to it. What about the other side, though? We'll have a little more complicated over on the left side because what do I have on the left side? A product. So to do the derivative of that product, stands to reason, I need to use product rule. Product rule says take the first times the derivative of the second. Well, doing the derivative with respect to t, so the derivative with respect to t of w would be dw dt. Plus the second times the derivative of the first, the ddt of L, would be dL dt, wouldn't it? 1 dL dt. Now I'm good to go, aren't I? I've got dA dt is negative 4. L I know is 10, so now just substitute. dA dt is negative 4, L is 10, dW dt, well, that's the one I'm looking for, don't know it. W is 8, dL dt is negative 1.5. So I have negative 4 equals 10 dW dt, and that would be negative 12. What do I do to solve for dW dt? Add 12, okay, so it'd be negative 4 plus 12. Be 8. So 8 equals dW dt. Divide by 10. So dW dt turns out to be 8 over 10, which is 4/5. What's the units? Units of W divided by units of time. Units of W, so that's going to be the same. I've got W up here, don't I? Meters. Units of time. Second. Now, an interesting little note here is the width increasing or decreasing? The area was decreasing, so was the length. But what about the width? It's a positive. Width is increasing. So even though the area is decreasing and the length is decreasing, the width is actually increasing to get those specific numbers out. Interesting note. Okay, but anyway. All right?